Okay, welcome to week 7, endocrine system. Okay, we're going to start with a basic overview of the endocrine system, how it works, and then we're going to specify on the thyroid, and specifically thyroid releasing hormone and thyroid stimulating hormone. All right, so that's the plan. Okay, so we're going to look at a general view of the endocrine system here to start with. Okay, basically looking at a 3-step process. Okay? So we're going to start with the hypothalamus, part of the brain. Okay, so obviously neural impulse is going to come down. Hypothalamus is going to release its own set of hormones. Okay, that hormone is going to travel through a little portal system, the hypothalamic hypophyseal portal system, which is a direct connect between the hypothalamus and the anterior pituitary. So this prevents the hypothalamic hormones from having to travel around the entire body, down to the heart, back up through the carotid, okay, to the anterior pituitary, and so it gives us a much more control and a much faster connection than traveling obviously all the way around the body. Okay, so we got direct connect, hypothalamus, release hormone, stimulates the anterior pituitary. Anterior pituitary is a gland just below the brain. Okay, and the anterior pituitary is going to release its own hormones. So the anterior pituitary is considered our master gland, okay, because it produces hormones that are designed to trigger everything else in the body, all the other endocrine glands. So it's more of a control gland than stimulates its own. It does produce a couple on its own, don't get me wrong. Okay? But so anterior pituitary is going to produce its own hormones. It's going to stimulate the glands throughout the body, like the adrenal gland, which is going to produce cortisol and epinephrine, norepinephrine. If we were doing stress response, we're going to focus on the thyroid, which is a different gland, obviously, in the neck, okay, which is going to control growth, development, okay, metabolism, okay, and it's going to so step 1, hypothalamus, hormones to trigger the anterior pituitary. Step 2, anterior pituitary is stimulated and releases its own hormones to stimulate glands throughout the body. Step 3, those glands are going to produce hormones to trigger everything else. Okay? We'll get the feedback loop at the end. Okay? But that's a basic idea of any endocrine gland. Like I said, we're going to focus on the thyroid. Okay? So basic steps here. Again, 1, 2, 3. Starting with the hypothalamus. Okay? Going down to the anterior pituitary and then to the thyroid. So let's get specific here. Hypothalamus is going to produce a hormone called TRH, which is short for thyroid releasing hormone. Okay? That thyroid releasing hormone is going to travel again through that capillary to capillary portal system. Okay? And it's going to stimulate the anterior pituitary to then create TSH, which is thyroid stimulating hormone. Okay? This is the hormone that will actually be sent out of the pituitary down into the, through the jugular vein, okay, to the heart, which will then hit the thyroid gland in the neck. Okay? And from there, we'll produce various enzymes out of or various hormones out of the thyroid, including T3 and T4. T3 is called thyroxine, okay, and T3 is triiodithriamine, okay, big long one. That's why they're abbreviated to T3 and T4. Okay, basically their function, okay, is increased metabolism is the main one that we're going to. So what increased metabolism is, it means we're burning energy faster in the body. So we're increasing heat, okay? We're using up ATP. In the same rate, we're going to increase the production of ATP, which means more oxygen needed for the body. We're going to increase our heart rate. It's also going to affect normal growth and development, okay? So thyroid has a pretty big impact on the body. Okay, so step 1, hypothalamus releases TRH, or thyroid releasing hormone. Step 2, you have your anterior pituitary, which is triggered by the TRH, and then releases a second hormone, thyroid stimulating hormone. okay, which is going to go through the body to the thyroid in the neck. The thyroid is then going to release T4 and T3, okay, which have various effects on the body, okay, including, as the main one, regulates our metabolism. Okay, so how quickly we break down energy, okay, or produce energy, I guess is a better word. Okay, the big control here is feedback. Okay, so when do we know to essentially when to release the hormones out of the hypothalamus, which will trigger the thyroid by steps, and when to shut it off as well. Okay, we don't want to produce so much that we're over contracting our heart, because it does increase heart rate. Okay, we don't want to produce so much that we're burning up all of our ATP store or all of our energy stores. Okay, we want to keep it at that normal level. Okay, so all of our hormones, with few exceptions, including oxytocin, are under negative feedback loops, and that's what this whole process, TRH, TSH, and T3, T4 are all under a negative feedback loop. What that means is that as we get too high, we can lower the levels. As we get too low, we can raise the levels. Okay, that's what negative feedback is in general. So negative feedback here, okay, basically as T3 and T4 levels increase in the blood to a certain extent, okay, what they're going to do is they're going to shut off at the hypothalamus. Okay, specifically, they're actually going to act at the DNA level, and they're going to block the transcription of the actual genes that would produce TRH, or thyroid releasing hormone, in the hypothalamus itself. So we're not actually going to even produce TRH, and it does the same thing for TSH in the pituitary. So it's going to act at the DNA level on transcription, okay, and block the activation of those genes. So no genes, no transcription, no proteins, no hormone. Okay, so it actually goes all the way down to the DNA level. Okay, our reference is Chimera 2009. Okay, and again, the article talks significantly about the feedback loops. Okay? The other part of this is that T3 actually blocks the translation. Okay, so if there's already genes transcribed, we already have the mRNA ready to, produce a protein. Okay, and therefore the protein will turn into the hormone. TSH or the translation of that mRNA is actually blocked by T3 levels. So we have a double control on this. We block the transcription all the way down at the DNA level, and then we block the translation level as well. And it prevents both TRH and TSH from being produced, okay, and therefore no activation of the thyroid. We will reduce the T3 and T4 levels. Okay, so negative feedback. We get too much thyroxine, too much of that of the T3, T4 in the blood. Okay, and what's going to happen is it's going to essentially block the activating hormones, the TRH and TSH, in both the hypothalamus and the pituitary. Then as T3 and T4 levels drop below, okay, then we'll have again the negative feedback. We'll activate the hypothalamus. Okay, it'll trigger, we'll release TRH, or we'll produce and release TRH. Okay, stimulate the anterior pituitary, stimulates or releases TSH, stimulates the thyroid, and we go back to producing these hormones T3 and T4 again. Okay, so we have this constant cycle that we can balance constantly in the body. It helps again maintain homeostasis. Okay, maintains balance. And we're looking at this basically for most of the endocrine glands are going to follow under the same suit. Okay, but specifically this is the activation of the thyroid. Okay. Anyway, so references to finish this off. Okay, main article we're looking at, again, a regulation of thyroid negative feedback was Chimera 2009. Okay, we also use the textbook for the information on the activation of the thyroid. That's Sherwood, 2015. Okay, and then of course our images there. Wikipedia was the first image. Med school thyroid physiology. The second one, Angelus. Okay, thyroid, again, a book, textbook, thyroid physiology. Okay, that was from Virginia Commonwealth. Thank you for the time.